Hi friends, we're back again for another math lesson. And remember that in our Unit 9, it's all on shapes. And so yesterday you did a Am I Ready for this unit? And I know that for many of you, you commented that it was really easy cheesy and you can't wait to get into some things that are a little more challenging. So let's try warm up this morning. I'm thinking of a number that is a 2-digit number that is even. And when I add the 2 digits together, the sum is 5. So think about that. It's a 2-digit number that I'm thinking of. When you add the 2 digits together, it equals 5. So I would have 2 digits that I would add together and I would get a 5, correct? So what 2 digits could I add together that would make a 5 that would be an even number? So let's try that. Who might have a good answer? Oh, I heard someone say maybe a 5 plus a 0. Oh, I don't seem to have any zeros right here in front of me, so I'm just going to put one like that. How about that? 5 plus 0 equals 5. And what is the 2-digit number I'm thinking of? Okay, maybe 50. It could be a 50, right? 5 and a 0, 50. It's even, right? And it has 2 digits, and when I add the digits together, it equals 5. Okay, maybe that's one of the numbers I'm thinking of, but not the number I'm thinking of. But it would be a good answer. All right, how about another one? Is there another good answer? What other numbers could I add together to make 5? Oh, I heard someone say a 4 and a 1. 4 plus 1 equals 5, right? 4 plus 1 equals 5. So let's think about that number, 41. Is it an even number? No. So that would not be a number that I'm thinking of, correct? All right, let's think of another number. Is there another answer yet? I heard someone say 2 plus 3. Okay, 2 plus 3 equals 5, correct? 2 plus 3 equals 5. All right, so when I put those two numbers together, I get 23. An even number? Oh no, so that's not one of the numbers I'm thinking of. Any more numbers I could think of? Oh, someone said if I do a turnaround fact or I change my addends, I can have a 1 plus a 4, right? A 1 plus a 4, and that number is 14. Is it an even number? Yeah, so maybe that's one of the numbers I am thinking of. What about if I turn the addends around in this number? A 0 and a 5. What number is that? 0 and a 5. What number is that? Oh, it's 5. Is that an even number? Oh no, so that's not one of the numbers I'm thinking of. Can I do a turnaround fact for here? I can. So I can make a 3 plus a 2, correct? 3 plus a 2. And the number is 32. Is it an even number? It is, so that could be a good number, right? And actually that was the number that I was thinking of, 32, but any of these others would be a good number as well, but the number I was thinking of was 32. So I really like that you did not stop your thinking whenever I gave you this warm-up, that you didn't just settle for one answer, because you can see that in this answer and in this warm-up, there were many good answers. So thanks for that warm-up, and let's get into our lesson right now. And our lesson today is on shapes. And I have a thinking question for you. Here it is, before I move my board. Are all rectangles squares, or are all squares rectangles? Think about that. Are all squares rectangles, or all rectangles squares? One of those statements is true, and one of those statements is false. Let's continue our lesson at the end. We'll prove which answer is true one and which one is false, okay? So I have for you a little poem that I thought of on squares and rectangles, okay? And the first one is called Sammy Square. Sammy Square is my name. My 4 sides are just the same. Turn me around, I don't care. I'm always the same. I'm Sammy Square. So again, no matter how you turn Sammy Square around, his sides are always the same, and he has 4. Here's Ricky Rectangle. Ricky Rectangle is my name. My four sides are not the same. Two are short and two are long. Count my sides, come along. 1, 2, 3, and 4. And what do you notice that is the same, though, about Sammy Square and Ricky Rectangle? What do you notice about them? Besides that they both have four sides, they both have sides that are closed, right? You remember that from kindergarten. In order for it to be a shape, it must be a closed-sided shape, which means that if one of those sides is open, it's not a true shape because other things can enter, other things can get in, and it can distort the shape and create a whole new shape if the sides are open. So we need to keep the sides closed in order for it to be a shape. But continue to think of our thinking question. Are all squares rectangles? Or are all rectangles squares? What do you think? So let's continue along with that. Maybe I'll just leave it up for you to look at while we continue with our lesson. So in your toolbox that you took home, you may have put some pattern blocks. And in your pattern blocks, if you have a square, like I had in my toolbox, or a rectangle, which was not in our pattern block, toolkit. I wonder why we didn't have any rectangles in that pattern block template. I'm going to think about that one too. That's another thinking question for us. But this lesson has lots of thinking questions. So I want you to think about that. Our rectangle and our square and the fact that they are always closed shapes. And squares and rectangles are very similar because a square is actually a very special kind of a rectangle because his rectangle sides are just all the same, right? Because on a rectangle, it said that sometimes my sides are short and sometimes my sides are long. And if they're all equal, then you become a square. But you cannot make a square become a rectangle because then it's no longer a square. But if you push the sides together in a rectangle, it can become a square. So hope you're listening to that to be able to solve at the end. Are all squares rectangles or are all rectangles squares? So something else very important to look at with our squares and rectangles, though, and our closed shapes. Both of them have four sides, but they also have something else very important to them. They have four corners. Do you see that? And these corners happen because the sides are closed. If the sides were open, you would not have true corners and they would not be a true shape. So because these sides are closed and they have four corners, we have a special math word for that. Do you remember what that math word is called for those closed corners on a square and a rectangle and on other shapes? They're called a vertex, right? When the sides come together and they meet at that point, it's called the vertex, right? And if they have more than one, it's called vertices, right? A vertex. So vertices are something in the corners of shapes. And rectangles and squares have four vertices and four sides. And that's what makes them unique. So really important that when you draw, if you're drawing your shapes, because you can't print the worksheets and you're just going to draw them, that you keep your corners, your vertices closed so that no other space can enter in. So on today's worksheet, you're going to see that you're going to practice counting how many sides and how many vertices on each shape. Really important to count them and to see which one matches the square or the rectangle. And then I'm going to ask you, because you're at home, and this is a really great lesson to do at home, to go around the house and see what kind of object you can find that would match a square or match a rectangle. And I've included an activity at the end where you can print it, and it's kind of an at-home sort where you can cut the pictures, and they're things that you might be able to find at home and match whether it goes under a rectangle or a square. So thank you for practicing our square and rectangle shape lesson today, and let's answer our question. Are all squares rectangles or are all rectangles squares? What do you think? You're right, all squares are rectangles. So, but not all rectangles are squares, right? So Thank you for our lesson today, and until the next time, stay well.